The reason we're going to prove number one is because all of your sum to product identities relates to one and only one product to sum identities. So the reason I picked this one is because notice in number one of your product to sum identity, we're adding sign functions. And the one we're about to prove, we're adding sign functions. Huh? You picked a good one? Yes. Good job. It really wouldn't have mattered. So that's the trick. So for the product to sum version, the one we previously did, pick two of your sum or difference identities and add or subtract them as needed. For your sum to product, that's the one we have on the screen right here, corresponded to the product to sum one. And then there's also another trick. We're going to use our new color. I don't know what the name is. All right, so previously in math class, we had the sine of x times the cosine of y is equal to 1/2 the sine of x plus y plus the sine of x minus y. So that's our product to sum identity. Any manipulation of this is allowed on both sides of the equation because we prove the identity to be true, so we can treat it like an equation. Namely, to make it a little bit easier, we can flop the sides around because it's an equation. That's comment number one. And comment number two, we can multiply both sides by 2 to get rid of that 1/2. So if I switch the sides and multiply both sides by 2, I would get the sine of x plus y plus the sine of x minus y. The flopping around is not a necessity. It just makes it easier to read. But notice the big picture. We're adding signs on the left. We have 2 times the sine cosine on the right. So we almost are where we need to be for our proof. Almost. But here's where the fun comes in. And this is how you prove all of them. It's sleight of hand. We're going to let x equal x plus y over 2. Then we're going to let y equal x minus y over 2. What the what? It's not cheating. An identity is true for any replacement of the variable. So I'm going to make all my x's x plus y over 2. I'm going to make all my y's x minus y over 2. Why? Because I can. So again, all the x's become x plus y over 2. All the y's become x minus y over 2. Fill it in. So we're going to have the sine of our new x, x plus y over 2, plus our new y, x minus y over 2, and now do it again, plus the sine of, but now it's x minus y, so x plus y over 2 minus x minus y over 2 equals to sine of our x cosine over y Well, notice that the right-hand side is done. It looks like what it needs to look like. So now we just need to simplify the left-hand side. What is x plus y over 2 plus x minus y over 2? X. Because if you add these fractions, and you can do that because they have the same denominator, what happens to the y's? Sure. And then you would have 2x over 2, which in most countries is x. So sine of x. Plus x plus y over 2 minus x minus y over 2. The x's cancel, and you'll have 2 minus negative y. I'm sorry, you'd have y minus negative y, which is 2y, over 2 is sine of y equals, you get to rewrite it and complain about it. Oh, I took too much. I was being greedy. I'll stop there. Copy. Oh, it's way up here. Paste. Oh my gosh. Oh gosh. I did something wrong. Is there an undo? Alright, can I paste it down here? Paste. Put it in the same place. I got it. It didn't undo. I thought it undid. Can I double undo? Oh, it's up there. Oh yeah. You. Anyways, we proved it to be true. That's all I'm gonna say. Oh my gosh. Sad face. Oh well. Good to go.